Hey students, I'm Professor Rajendra Bade. Thank you for joining me. Today in this video, I'm going to tell you how you can find resultant of a parallel system of forces in a plane. So let's begin. Parallel system of forces in a plane. Here is one example of parallel system of forces. All forces are vertical. In parallel system of forces, only two possible directions which are equally opposite to each other. For example, here it is upward direction, here it is downward direction. Here is one more example of parallel system of forces. All forces are parallel to each other, making an angle theta with the horizontal. Here also, as I told you, in parallel system of forces only two directions are possible which are exactly opposite to each other, and therefore in parallel system of forces, to add forces you need not resolve the forces, just positive negative signs are enough to consider direction of the forces. Here F1, if you consider this direction as negative, then minus F1, minus F2 and plus F3. This is how you can add the three forces. A system of forces in which the lines of all forces are parallel to each other is a parallel system of forces. So let's study how to find a resultant of parallel system of forces. Here is a system of forces in which all forces are vertical. So we already know that resultant is vertical. In this diagram, all forces are horizontal, so we already know that resultant is horizontal. Remember, in case of parallel system of forces, angle made by line of resultant force with horizontal, that is angle theta, is not unknown. If all forces are vertical, resultant is vertical. If all forces are horizontal, resultant is horizontal. And if all forces make say angle 30 degrees with horizontal, resultant also makes angle 30 degrees with horizontal. So remember, out of the three parameters of resultant are theta and d, magnitude, angle of the line and distance. Theta will be known to you always in parallel system of forces in a plane. Then how to find resultant r and its distance from a reference point? We use these two equations. R is equal to sigma f. When you use this equation, you get magnitude and direction of the resultant force. You will understand it better when we start solving problems. And the second equation is actually a Varignan's theorem. It states that sum of moments of all forces in a system is nothing but moment of the resultant about the same moment center. Moment of these four black colored forces about point A is equal to moment of this resultant force about point A, where d is a perpendicular distance of the line of the resultant force from the moment center. So this distance d is a perpendicular distance of resultant from the moment center. So if resultant is vertical, then d is horizontal. So if all forces are vertical, then the resultant is vertical and d is horizontal distance. Check here. If all forces are horizontal, then the resultant is horizontal and d is vertical distance. These three forces are parallel to each other. So it's a parallel system of forces. All forces are making angle theta with the horizontal. That means resultant is also making angle theta with the horizontal. When you use this equation, remember you need not resolve the forces. R is equal to sigma f. Take F2 and F3 positive. This direction as positive. Then F1 will be negative. So minus F1 plus F2 plus F3. This is how you can add the forces. And if you get positive answer, then that means resultant is in this positive direction. And if you get negative answer, that means resultant is in the negative direction. But whatever, angle of line of resultant will be the theta. So angle of line of resultant is not unknown, but magnitude of the resultant r you will get from this equation, and the distance of the line of resultant from the chosen moment center you will get by applying this Varignan's theorem, where you know now that d is perpendicular distance of the line of resultant from the moment center. If resultant makes angle theta with horizontal, then d makes angle theta with the vertical. So this is how you should measure d and show the line of the resultant. And here is the resultant. If resultant makes angle theta with horizontal, it's better to show horizontal distance of the resultant from the moment center. Now, how to find horizontal distance of the resultant from the moment center? Simple. Resultant makes angle theta because all forces makes angle theta, and therefore focus on this right angle triangle. Hypotenuse of the right angle triangle opposite to 90 degrees angle hypotenuse. Let it be x. Then horizontal distance is x is equal to d by sine theta. Remember, this angle theta will appear here. So opposite side by hypotenuse, x divided by d, that is sine theta, and therefore x is equal to d by sine theta. Similarly, if you want to find vertical distance of the resultant from the moment center, this is how you will be able to find out y is equal to d by cos theta. When the resultant is an inclined force making an angle theta with the horizontal, then you may be asked to find horizontal vertical distances of line of resultant from the moment center or from a particular point. Remember these two expressions, x is equal to d by sine theta, y is equal to d by cos theta. Using Varignon's theorem, you find d, and once you get d, in no time you get horizontal and vertical distances also, where d is perpendicular distance. D is perpendicular distance. Read this problem. Find a resultant of a parallel system of forces shown in figure. This is the diagram given with the question. Now, to solve problem, you will have to draw a neat space diagram. So here I have drawn the space diagram. So when you draw space diagram, to solve the problem, when you draw a space diagram, it is not necessary to show the rods with double line. But all dimensions are very important because you are going to take moments of all forces. So space diagram is diagram showing magnitudes of all forces, directions of all forces, and the distances of all forces. Remember, all these three parameters, magnitude, direction, and point of application, must be very clear in the space diagram. So draw neat space diagram. In the space diagram, show all given forces and couples. Of course, here there is no couple here, but in general I am saying, show all given forces and couples as they are in original diagram. So I have shown all these forces in my space diagram, and then if we are going to use those two equations in order, so R is equal to sigma F. So here these are the four forces we are going to add. So 250 minus 150, this is downward force, then plus 100 and plus 200, plus 100 and plus 200. So we have found out resultant. Resultant is positive answer. That means it is upwards. All forces are vertical. We have considered upward direction positive. We got positive answer. So resultant is upwards. So be very careful about the direction of the resultant. And then by Varignon's theorem, sum of moments of all forces in a system equal to moment of resultant. Let's write moment of all these four forces about point A. Why point A? So listen, it is your choice. You can use moment center point C. You may use moment center point D or point B. Remember, any well-defined point in the plane can be chosen as the moment center. Of course, you should choose such a point from where all distances are easily available to find moments. So here we have chosen point A. Now you have already studied, you have already studied resultant of concurrent system of forces. If you have not watched that video, watch that video. Link for the video is given here. So refer this video for resultant of concurrent system of forces. Now here, first time we are using Varignon's theorem, sum of moments of all forces on the right side and moment of resultant on the left side. So R into D. Now this part you try to understand. Here you are going to use magnitude of the resultant. Whatever, even if you got negative answer for R, here you are not going to use that negative sign, because this is the expression in which you are going to consider not a direction of forces but direction of moments. So 400 into D. Now what is direction of this moment, clockwise or anti-clockwise? Listen carefully. Right now we don't know where the resultant is. We are not sure whether direction of moment of the resultant about the chosen moment center A is clockwise or anti-clockwise. So we have not used a negative sign. That means we have considered a positive moment, that is anti-clockwise moment. So in this calculations, we have assumed that moment of resultant about the moment center is anti-clockwise. Now, when you are not sure about direction of moment, it is better to assume anti-clockwise. So we have considered here anti-clockwise direction. So 400 into d, why anti-clockwise? It's simply assumption. And then now moment of 250 Newton force about point A is 0. Moment of 150 vertical force into horizontal distance, it's clockwise moment. Then 100 into 5 anti-clockwise moment. Then 200 into 7, that is anti-clockwise moment. Solve this equation and you will get d is equal to 3.625 meters. Now once again, listen, this is very first problem we are solving on parallel system, so all minor details you must know it here. And really speaking, there is nothing like minor. Any small mistake and you get wrong answers. So be careful. So d is equal to 3.625 meters, that is distance, perpendicular distance. Resultant is vertical, so d is horizontal distance from the chosen moment center. But what I am telling you here is, it all depends on what is the problem. Sometimes you may get negative answer for d. Now, if you get d negative, then how to interpret that negative answer? Try to understand. D is a distance, it is not vector quantity. Suppose you get value of d negative, then it means assumption made earlier in the calculation is wrong. And what is that assumption you have made in these calculations? Moment of resultant is anti-clockwise, which will be wrong in that case, and you will say moment of resultant about the moment center as clockwise. In short, if you get d positive, then moment of resultant is anti-clockwise, and if you get d negative, then moment of resultant is clockwise. Note down it somewhere. It's very important. Okay. Now let's proceed. We have found out R, we have found out D. Now next thing is to locate resultant in the space diagram. Now how to show resultant in the space diagram? Remember, D is horizontal distance of resultant. Resultant is vertical. All forces are vertical. Resultant is vertical. If resultant is vertical, distance D is horizontal. So this is horizontal distance from point A. But whether we should measure this distance on the right side of point A or on the left side of point A, that decision you will have to take. So how to take that decision? Simply visualize this vector, resultant vector, in the space diagram. In this case, D is positive. So moment of resultant about point A is anti-clockwise. Now let's show resultant in the space diagram. D is horizontal distance from point A, but whether it is to be measured on the right side or left side, that decision you will have to take. And how to take that decision? Listen. This information is going to help you to locate resultant in the space diagram. We should locate resultant in the space diagram so that resultant must have anti-clockwise direction of moment about point A. Okay. So vertical force, check here. If you place, so this is how you visualize. So if we place the resultant here on the left side of point A, then the resultant will have clockwise moment. And if you place it on the right side, resultant will have anti-clockwise moment. So this information is very important. It is anti-clockwise moment, therefore this is not the correct position, because this position of resultant gives you clockwise moment. So decision we have taken that resultant is on the right side of point A. So now properly show resultant at distance 3.625 meter on the right side. Be sure you have understood how to take that decision that resultant is on the right side of point A. So show resultant, this is distance 3 meters, so slightly greater than 3. Show the resultant this way, 3.625 meters. And now write answer properly. Resultant 400 Newton, properly in the sense magnitude, direction and line of action. So 400 Newton upwards, magnitude and direction. And now line of action 3.625 meters on the right side of point A. So that is what I have mentioned here. Okay, let's proceed for the next problem. Replace the following system of forces by its simplest equivalent. Remember, to find simplest equivalent means to find a resultant. So first thing what you are going to do is to draw space diagram. When distributed forces are acting on a rigid body, then you should replace distributed forces by point forces. Now here there is uniformly varying load. Here it is uniformly distributed load. If you don't know how to replace distributed forces by point forces, then check that video. Its link is given here, and also I have mentioned that link in the description. So check that video. It's very short video, but that's important. Now what I'm telling you, listen. Because of presence of distributed forces, diagram may appear little congested or complicated, but really speaking, it's very straightforward problem because you are going to replace these two distributed forces by corresponding point forces. So let's draw space diagram. So first of all, the rod ABC, which is 6 plus 5, size, shape of body and all given dimensions are always very important. Insert all given forces and couples as they are in the given diagram. So here it is 250 Newton upward force clockwise couple, 150 Newton downward force anti-clockwise couple, everything as it is given. Only thing is now you should replace this distributed forces. So there are two more forces here, one UVL, uniformly varying load, and UDL, uniformly distributed load. So how to show triangular load? It's simple. 1/3 of its length. What is length of this triangular load? 6 meters. So 1/3 of 6, 2 meters. 1/3 of its length you are going to measure, that is 2 meters you are going to measure from maximum intensity end of the triangle. So this is the triangle. Height of the triangle is gradually increasing and maximum height of the triangle is at point B. So from maximum intensity end, from point B at distance 2 meters, you are going to show that force. So from point B 2 meters, that means from point A 4 meters. Now how come 240 Newton? As if you are finding area of triangle. Remember the logic of area, base into height by 2, area of triangle formula. Basically it is average intensity into length. So what is average intensity? Here intensity is 0, here intensity maximum 80 Newton per meter. So average 0 plus 80 divided by 2, that is 40 into 6. But what I am telling you, remember it as if you are finding area of a triangle. So 6 into 80 by 2, that is its magnitude. Direction downwards, that is already mentioned here in this triangle. Direction is very clear, downward force it is. So UVL is downward force. Now what about rectangular load here, or UDL? UDL to be shown at the center. So length of the UDL is 5 meters, 2.5 meters and 2.5 meters. And at the center, how much is the force? 40 into 5, 200 Newton. 40 Newton per meter over 5 meter length. So 40 into 5, and you have found out the magnitude. So actually it is the space diagram we have drawn to solve the problem. In the space diagram, all forces and couples as they are in given diagram, and if in the given diagram there are distributed forces, you must replace the distributed forces by point forces. Okay, so this is the space diagram. Now add the forces. R is equal to sigma F. So R is equal to, while adding forces, don't consider couples, because a couple is zero force. If you don't know this, I made a video on couple exclusively. Watch the video, be sure you have understood what exactly couple is. That's very important. So here is that video link. Also the link is given in the description. Okay, so R is equal to sigma F. R is equal to 250 upwards, 240 downwards, 200 downwards and 150 downwards. And this is how you have found out R, minus 340. Now all forces are vertical. Along a vertical, now all forces are vertical. That means resultant is vertical. and along a vertical line negative is downwards, so I have shown the direction downwards. Now R into D equal to sigma m. These are the two equations we use. R is equal to sigma f, R into D equal to sigma m. So 340 into D, 340, that is resultant. Remember once again, resultant is downwards, that's why you are negative sign here. But when you write the moment equation, do not use negative sign of resultant, because in moment equation we should consider direction of the moment and not the direction of the force. Now where is the resultant here in the space diagram? That is to be found out. That means at this stage we don't know where the resultant is. So we have assumed the moment of resultant about point A as anticlockwise. So positive sign because moment of resultant is assumed anticlockwise. That is equal to minus 100 because it is clockwise moment. Then moment of 250 Newton force is 0. 240 into 4 clockwise. 200 into 8.5 clockwise. Then 150 into 11. 150 into 11, that is clockwise moment. And there is anti-clockwise couple 150. Remember, couple is already a moment. Don't multiply it by the distance. So it is already a moment in Newton meter. So don't multiply it again by distance. Only check the direction of this moment. It is 150 anti-clockwise. So in addition of moments, that is in sigma ma expression, magnitude of the couple and its direction are to be considered, and no distance is required here from the moment center. And we got D as minus 12.53. Minus 12.53. Negative answer. That suggests you that moment of resultant, as I have explained you in earlier problem, moment of resultant about point A is clockwise. What is interpretation of this negative sign? Moment of resultant about point A is clockwise. So I mentioned here. And this direction of moment of resultant, what you have identified now after completing these calculations, this direction is going to help you to locate resultant in the space diagram. What we have identified up till now, resultant is 340 Newton downward force and its distance from point A is 12.53 meters. Negative sign suggested us that moment of resultant about point A is clockwise. So let's proceed. I have visualized resultant on these two sides. First decision will take whether it should be on the left side or right side. Now when resultant is on the left side, it gives about point A anti-clockwise direction of moment. So this is not the correct position of the resultant. Moment of resultant must have clockwise direction. So this is not correct. This is the correct position. But we'll show it at distance 12.53 meters. So show it 12.53 meters resultant. Length of the rod is 11 meters. So from point A at distance 12.53 meters. Remember, distance is a vector quantity, so you don't use this negative sign in the final answer. So let's write the answer. R is equal to 340 Newton downwards, 12.53 meters on the right of point E. Let's proceed with this problem. Be careful. Forces are given in kilonewton, distances are in meter, so moment will be kilonewton into meter. For example, here this couple is 20 kilonewton meter. Now first we will draw the space diagram. In space diagram we should show all given forces as they are, and if there is distributed force, replace it by point force. It is uniformly distributed force. So total magnitude is 3 into 5, 15 kilonewton acting at the center. So here is that rod. Insert all dimensions properly. All given dimensions are very important. Show all given forces and couples as they are in given diagram and replace distributed force by point force. It is UDL, uniformly distributed force, to be shown at center of its length, that is 2.5 meters from A and 2.5 meters from B, because total length is 5 meters. And magnitude as if you are finding area of this rectangle, so 3 into 5, 15 kilonewton. Once the space diagram is ready, the two equations R is equal to sigma f and the Varignon's theorem R into D equal to sigma m going to give you the final answers. So let's proceed. R is equal to sigma f. So therefore R is equal to 25 positive, 15 positive, 10 positive, and don't consider couples while adding forces. So you got R is equal to 50 kilonewton. Positive answer means it is rightwards. Now R into D is equal to sigma m, sum of moment. Any point you can choose as moment center. So you can choose A or B or C. I've chosen point C as moment center. Remember, now you will get distance D from point C. D is a perpendicular distance of resultant from point C. Resultant is horizontal, that means this distance D in this problem is vertical distance from point C. Okay, so let's substitute the value. So R is 50D, R is 50 and D distance to be found out, and moment of resultant we have assumed as usual anti-clockwise. That's why I have not used negative sign here. And then anti-clockwise couple, so plus 20. Then horizontal force into vertical distance, 10 into 2 clockwise, then 15 into 4.5 clockwise, then 25 into 7 clockwise, and you will get D as minus 4.85. Interpret this negative sign. Moment of resultant about point C is clockwise. Mention that. Moment of resultant about point C is clockwise. This is the distance of resultant from point C. Whether it is below point C or above point C, let's check it. If we imagine or visualize the resultant below point C, then it will have anti-clockwise moment, and if we visualize it above point C, it gives clockwise moment. This is not the correct position. This is the correct position. Now, at distance 4.85 meter, let's show the resultant properly. So here is the resultant. Take care of proportion. 2 plus 2.5, that is up to here 15 kilonewton force, it is 4.5, and slightly above that I have shown the resultant, which is at distance 4.85 meters. This negative sign simply suggested us that our assumption made earlier was wrong. So moment of resultant is not anti-clockwise. And let's answer properly. R is equal to 50 kilonewton rightwards, 4.85 meters above point C. One more problem here. Find resultant of the parallel system of forces shown in figure with respect to point C. Now when you draw space diagram, all given dimensions are very important, all forces and couples as they are, but if there are inclined forces in the diagram, you should show angle of those forces either with vertical or with horizontal. So here all forces as they are, but what is angle between the line and the force vector given? 90 degrees. If a line makes angle 30 degrees with horizontal, its perpendicular must make angle 30 degrees with vertical, and that is why I have mentioned these angles here. Insert all dimensions. So 5 sine 30, that is 2.5, and horizontal length is 5 cos 30, that is 4.33. So this is how vertical horizontal distances also I have mentioned. Now let's proceed with the two equations. R is equal to sigma f. So R, remember, resolution of forces not required. We'll consider this direction as positive and add the forces. So plus 17, plus 13, plus 10, and don't consider couples while adding forces. So we have found out resultant 40 Newton, 30 degrees with the vertical. Now R into D equal to sigma m. Let's put the values. 40D. 40 is magnitude of the resultant, D is perpendicular distance of the resultant, and the moment is anti-clockwise. That is what is our assumption, because right now we don't know where the resultant is. And plus 7, that is anti-clockwise couple. Don't multiply it by distance again because it is already a moment. We have chosen C as the moment center. So we'll get distance D from point C. So moment of 13 Newton force about point C is 0. Now 17 Newton force. You must know now how to find moment of a force about a point. If you don't know, I have made a video on moment of a force about a point. Link of the video is given below in the description, or here is the link of the video. Watch that video. Okay, so visualize components of this force. 70 Newton. Horizontal component is sine 30, 17 sine 30 into vertical distance 2.5. And at point B, remember this force is at point B, so components are at point B. So what is moment of vertical component about point C? 0. So this is that total moment of 70 Newton force. Similarly, 10 Newton force. Watch the diagram. Visualize the components here at point A. So you realize here that moment of horizontal component is 0 about point C. That is because point C is on the line of horizontal component. So vertical component 10 cos 30 into 4.33. Vertical component into horizontal distance. So this is how we have written the moment of all forces, and you will get D as 0.581 meter. Anti-clockwise direction of moment, that is what it suggests you. Earlier problem we solved, in all those problems resultant was either vertical or horizontal according to the forces involved in the system. In this case, all forces make 30 degrees with vertical, so resultant also makes 30 degrees with vertical. So D is perpendicular distance, that makes 30 degrees with horizontal. If a line makes 30 degrees with vertical, it's perpendicular, that means D makes 30 degrees with horizontal. So this distance is not horizontal, it's not vertical, but it is to be measured at an angle 30 degrees. But to simplify the process of showing resultant in the space diagram, it is better to find horizontal distance, and in no time you get that. Just divide D by sin theta. In this case, theta is 60 degrees. Theta is angle made by resultant with horizontal. Angle made by resultant with vertical is 30 degrees, means angle made by resultant with horizontal is 60 degrees. So D by sin theta, and you have found out distance x. So this is horizontal distance of resultant from point C. Now let's locate resultant in the space diagram. As usual, either resultant is on the left side or on the right side, but wait. Resultant must have anti-clockwise direction. So this resultant's position suggests you clockwise direction of moment, so it is not correct. So correct position is on the right side of point C. So on the right side of point C, show the resultant. So from point C, on the right side, I have measured 0.6, measured in the sense I have shown it, 0.671 meter. And at this point, I'll show at this point. It is horizontal distance 0.671. At this point, we'll show the resultant 40 Newton at an angle 30 degrees with vertical or 60 degrees with horizontal. And write the answer properly. R is equal to 40 Newton, rightwards upwards 60 degrees with horizontal and 0.61 meter to the right of point C. So that's it. It's very easy to find resultant of a parallel system of forces in a plane. I am going to make one more video on resultant of parallel system of forces where some more variety of problems we'll try to solve. So like the video, share the video. If you have any doubts or suggestions, leave comments below and don't forget to subscribe my channel. Thank you.